We are, of course, talking about DNS rebinding attacks with Matt Dobinson. And he's a senior security consultant for Context IS and a researcher. And yeah, this is about DNS rebinding. I was told over a beer the other night, there's a pretty decent example of the use of DNS rebinding in this talk. It only goes for half an hour, but yeah, I'm really looking forward to this one. Give it up for Matt Dobinson.
Okay, so this is my talk on breaking with DNS rebinding. It's named that way because I'll actually go into a bit of a demo of breaking into a smart home using DNS rebinding. But we'll go over what is DNS rebinding, how it came to be, what tools you can use to test for it or to actually exploit it. We'll do the short demo on breaking into a smart home, and then we'll delve into my struggles with getting developers to actually remediate some of these issues, and also what protections are available to defend against it. So, since I'm not a well-known Uber hacker like Silvio, a little bit about me first. Like Pat said, my name's Matt Dobinson, but everyone calls me Geckom, unless you're my wife or mother. I'm a senior security consultant for Context Security in Brisbane. I've got a long work history of being an ex-software developer. So I've developed in most languages, particularly around web. I have a bunch of certificates, mostly from OffSec. Like everyone in InfoSec, I'm on Twitter if you want to follow me. Basically, I just like breaking into things, pulling things apart and tinkering with bits and pieces. So I'm a contributor to various conferences, meetups, trainings, etc. So I'm staff today as well as speaker and helping with the CTF and everything else. And I'm not really hacker man, for those who didn't quite spot that. Okay, so what is DNS rebinding? DNS rebinding is a form of computer attack in which a malicious web page causes a visitor to run client-side scripts that attack a machine elsewhere on the network. In theory, same origin policy prevents this form of attack from happening. Client-side scripts are only allowed to access content on the same host that they were served from. Comparing domain names is an essential part of enforcing this policy. So DNS rebinding circumvents this protection by abusing the domain name system and essentially changing the IP address of the domain halfway through the attack. This attack can be used to breach a private network by causing the victim's web browser to access computers on private IP addresses inside of the private network and return the results to the attacker. It can be used for spamming, denial of service attacks, and tons of other malicious activities. So, some important facts before we get too much into it. It was first discovered in 28th of April 2007 by Stanford Security Labs, so it's been around for a very long time now. 12 years later, it's still a internet riddled with rebinding issues. So if you're a security researcher or pen tester or even just a developer, it's something you should really look into, or come see this talk, I guess. A friend of mine likes to compare it to cross-site scripting attack, or a reflected cross-site scripting attack, because it essentially lets you run JavaScript code on a target website that you should not be able to run JavaScript on. Disabling cores doesn't really help. You're still kind of vulnerable to a DNS rebinding attack. And most of the research I've seen on it is people mostly targeting modems, routers, that type of thing. But it's starting to get a bit more publicised these days, and you can do some pretty interesting things with certain JSON RPC ports. So I'll go into a couple of examples of that too. So a bit of a timeline. Like I said, it was discovered in 2007 by Stanford. Later that year, Sun Java and Adobe fixed some of their stuff, and then pretty much everything went dead. I mean, there were a few examples of it, but not much happened until early 2018, when Travis, in his usual style, just dropped a whole bunch of DNS rebinding issues. So there was World of Warcraft's RPC server, which I believe let you screw with other people's accounts, which is, always fun. And my particular favourite is his uTorrent DNS rebinding attack, because uTorrent, for those of you that haven't used it before, it lets you download a torrent to a particular directory, which in itself isn't particularly nasty. Once you roll in DNS rebinding, you're getting someone else to add your torrent, aka a reverse shell or malware, whatever you want to install, straight into their startup directory. So that can be quite fun. And then in June, Brandon Dorsey discovers DNS rebinding in Google Home, Chromecast, and a bunch of other common IoT type stuff. and I believe that's all patched now. So how does the DNS rebinding attack work? Well, it's fairly simple actually. It shouldn't work, but when you hit a malicious domain that's been set up for DNS rebinding, the browser will request the domain, so evil.com in this case, and they'll get back an internet-facing IP address. So in this example, it's 1.2.3.4, and the server returns some JavaScript and HTML code, and it keeps trying to resolve that domain over and over and over again. So in my example, I do it every 3 or 4 seconds. And then after a while, so usually after the payload or the JavaScript is being delivered to the browser, the DNS server will then change, go, hey, I'm not that internet-facing IP address, I'm actually one of your internal web servers. So at that point, approximately 1 to 2 minutes, the browser starts requesting content from evil.com at your internal server IP address. So instead of pointing to the internet, it's pointing to some internal web service that you're running, uTorrent, World of Warcraft, whatever. And at that point, you're essentially running JavaScript on their website. So you can access the internal IP address without any of the pesky same origin policies that are a bit painful to bypass. And you're basically bypassing the firewall at that point because you're leveraging someone else's machine just by visiting a website. Okay, so rebinding tools. I think there's a couple of NCC guys here, but they've got a tool called Singularity that's really good. It's very complete. I think it's got a GUI, it's a good setup, really good tool. There's DNS Rebinding by Lorenzog. My personal favourite though is Travis's Rebinder, or I'm not sure how you say that.
It's Tavis, not Travis.
Tavis, sorry.
Tavis.
It's my favourite anyway because it's very, very simple. It's highly flexible and it basically just does the DNS part of it, so you can write your own JavaScript. And of course there's MWR's DNS rebinding exploitation framework, which is very good if you're actually building a full attack instead of just testing it. Okay, so case study. I started looking to this a while ago after Tavis put in his World of Warcraft exploit. I believe when that became available, I started looking at it a little bit. But I wanted to target things I had running in my house. And for those of you that know me, I'm big into home automation. I'm pretty lazy, so I like to have things just turn on for me. So routers and IoT are pretty commonly targeted, but I wanted to focus on software in particular. So I looked at home automation that controls the IoT. I figure instead of trying to pop a webcam or a smart lock or anything like that, why not pop them all in one go? So as my job as a pen tester and red teaming, I kind of like to break things both virtually and physically. So smart homes are great for me because I can hack into it virtually and unlock the doors. So this particular software has over 30,000 active forum users, but many, many more people have it installed. I couldn't actually find exact numbers. And this particular software, it has no authentication over the local network, so that makes it really fun to exploit.
Stop being a coward and tell us who it is.
So I'll get to that in a minute. Another really handy one about this particular home automation software is it has a really nice little module that you can install that lets you run shell commands. So you can use this to just pop a shell, but that's no fun. I want to do something a bit different. So to answer your question, the developer was notified on the 2nd of February 2018. It still exists in the Bleeding Edge branch today. So I'm not going to release the code. You'll probably be able to Well, you'll actually see in the video, if you download my slides, you can actually go and see the code. But
Yeah, but I mean, if you told them a year ago, come on.
yeah. You will have all the tools to do it, so it doesn't take a lot. I'm pretty sure with half an hour you could probably rewrite this. Okay, so since I don't trust the demo gods to be lenient on me, because this is my first conference talk, I've pre-recorded this demo, mostly so that internet doesn't crash halfway through, and also so I can talk you through it. The exploit will let you send a malicious link to anyone on the network, anyone on the internet, which is running this particular home automation software, and it will retrieve their address, send it back to the attacker, and unlock any doors they have set up to the system. This particular home automation software has a few perks which make it great. Like I said before, it's unauthenticated over the local network, so we don't have to worry about any pesky authentication, and you can control almost everything in your smart home through API requests. So I'm going to spin up a DNS server, which changes between an internet IP address and a LAN IP address. Then we'll deliver some JavaScript code and poll the host name until the IP address changes, and then it will start making API calls to the REST API and start looking for doors that are available, send a request to unlock them, and then grab the location, send it back to me. I do not advise using this to actually break into anyone's house, which is the other reason why I'm not releasing everything. It's merely a case study to show the potential impact of this issue. Okay, so a few code snippets. I'll try and keep it fairly brief. To give everyone some insight into the code, there's two main parts to it. The code is all jammed into a single Python script, so it's fairly easy to use. This part here in particular is the DNS response. So it's, for those that know DNS, this is just a record for a DNS being returned. I didn't actually pull apart all the packets, I pretty much just copied it in. And yeah, the top part where it says if payload equals false is where it actually changes between the two IP addresses. So as soon as they hit the website and get the payload code, the DNS server will then change to point to the other IP address. Okay, and the second part is probably the main part about DNS rebinding. It's the JavaScript function. So I don't know if we've got many web developers here, but the bottom line here, the set interval function, calls a poller, so every 3 seconds it'll try requesting the same URL over and over and over again. Your attack server won't have this URL set up on it, so it'll get a 404 error, and when eventually it hits the internal website, it'll return a 200 standard response, successful HTML, and that's where you'll launch your attack and do your exfiltration and those kind of things. There we go. Okay, so I know the text is a little bit small to see here, but essentially this window here is your attack server, and all the client-side attack will happen on this same machine. So this is showing that it is actually an internet-based IP address, and it's running on secure webmail.xyz, a nice non-suspect domain name. And this is the code, so like I said, if you do want the source code, you can go through this video and retype it all out if you really want. But I haven't actually stolen it from anywhere, I wrote this all myself, so it shows a bit of that. So yeah, this script is designed so you can reuse it on multiple different people. So you pass the port that you want to attack, because obviously it's not always going to be port 80 or 443, the domain that you want to use to actually rebind with, and your internet-facing IP address, as well as the target IP address. There are some cool ways that you can use WebSockets and subdomains to actually go through the entire subnet and find out where the server is. I tried to keep this relatively simple.
I was going to ask about that, is like, how do you know what internal range someone is using? Do you just cycle through every single reserved range until you hit something? Or
I believe if you look at Beef, there are ways that you can pull down their local IP address and then just go through that subnet, which I've done, but it's a little bit more complicated. I wanted to keep this particularly simple. So on the right-hand side is the smart home. So as you can see, everything should now be closed. There's a front door and a garage door, as well as a light. All of those have been closed before we run the test. And then you send this nice little phishing domain to someone. And since it takes about a minute on Firefox, but it can take up to about 2 minutes to actually fully work, include a nice cat video, because who doesn't love a cat video? And I do apologise, you probably can't see that text too well, but on the bottom in the Network Explorer, you'll see the same config domain being called, sorry, config URL being called over and over again.
let's say Eclipse start home. Is that right?
Sorry?
Eclipse start home?
That's the framework that it was built on. So that gives you a good hint. But yeah, you can see in the request headers that it's calling a Python server currently. So it'll keep polling that over and over again, and after precisely a minute in both Firefox and Chrome, the DNS lease will actually release, and then it will bind to the new internal IP address in about 10 seconds. So it's a little bit of a slow attack. There are actually ways to speed it up, but it gets a little bit more complex again. And frankly, it's pretty easy to keep someone on a website for 1 minute anyway with a nice cat video. So there you go. It's rebinded to the internal server. You can see the server header is actually calling a Jetty version 9 web server, which is the Java library this particular application uses. That was just the GPS coordinates of this particular smart home, which we will exfiltrate in a minute. And here is where it's actually going through a REST API call that pulls down all the objects that are in the smart home. And it'll iterate through each one of those that includes the word door, and we'll send a post request that says turn this on, which in smart home terms basically means open that door. So there we go. On the right hand side you'll see front door is opened and garage door is opened, and that all happened in less than a second. I think all those 3 requests happened. And then the very last request down the bottom, it's a call back to the original attacking server. That base64 is all the data that I wanted to pull out of that system, which is primarily the what was opened and where the house is actually located. So it pulls all that out, sends it back to my attack server. So you can see in this particular case, 71 Eagle Street, which is actually our offices. It's got the garage door and front door now unlocked.
I guess the nice thing is because the target needs to actually be on their home network, you know, when you're opening up their garage door, they're actually there.
Yeah, well, I mean, I tried to keep this as a fairly simple
I was just
demo.
thinking, you know, cute cat pictures, click, garage door opens.
So
what the hell, man?
So bear in mind, this is also a smart home software that lets you run shell scripts, right? So I could just upload a simple bash script that says, wait until there's no motion in the house and then, you know, go and unlock the doors and shoot me an email to let me know they're all unlocked.
Nice. Very nice.
The original version I had on this too actually pulled up Google Maps, and then it put down the location of the smart home, where you were, figures out a route there, and then, yeah, comes back.
Did it also suggest a Bunnings on the way where you could buy a crowbar? Like, maybe that's a feature you want to include.
We might need to talk more about that one, but no, it would work out that it's about half an hour away, and then it would actually set a timer to pop the doors open when you get there.
That's pretty sweet. That's pretty good.
Okay, so what's the underlying problems here? So to me, the biggest issue here, and it's debatable, but the biggest issue is it uses Jetty, which by itself isn't an issue, I guess, but it's a commonly used Java library. So it's used in tons of different bits of software. Google shows pretty much no results for Jetty and DNS rebinding, so I don't think anyone has actually looked at this before. And while Jetty actually has the functionality to pull down a host header, which is what you need to defend against this attack, I guess for a bit of clarification, so what they should have been doing is checking that the host header is a valid host, because those HTTP requests that I sent to their server, it would have said the host is maliciousdomain.com. So if they'd validated that and denied access, it wouldn't be a problem at all. I wouldn't be able to do it. Of course, the better solution here would probably be to add some protections into the underlying library. So after I got to this point, I thought, you know, well, that's interesting. So Jetty actually doesn't have any protections by default built into it, right? So what else runs Jetty? So I go to their website and I find their Powered by Jetty page. There's quite a lot of things powered by Jetty. So all these products have a high probability, I guess, of being vulnerable to varying degrees. However, I haven't confirmed them all, so I'm not saying all these people are vulnerable. The home automation demo was particularly worrying because of the lack of authentication. So if you're looking for some exploits, you know, go through this list and find ones that don't have local network authentication.
Could you write a JavaScript brute forcer though? I mean, it'd be slow, but...
Yeah, theoretically. There are many more in this list. I couldn't fit them all onto one slide, unfortunately. I tested, I think there was something like 200 or 500 on their list alone, let alone the other ones out there. I ended up going through about 10 to 15 of these software packages from the list. Every single one of them was vulnerable, which doesn't bode well for the rest. But in most of the cases, you needed to actually log in somewhere, usually for the REST API endpoint. So I know a lot of attackers in this room, in this case, you're just going to go and find a nice data breach, grab some creds from there, and then build it into your DNS rebinding. So even though you have authentication, it's not really a fix for the problem.
And this is why, people should change their default creds on internal stuff, which they often do, because...
Well, preferably two-factor as well, but yeah, anything you can do. So DNS rebinding issues present in tons of web server libraries. I'm just using this as one example, but most of the ones I looked at had similar issues. So the problem. Software libraries aren't including methods to easily validate this header. There is no reason they couldn't put in methods to force you to actually validate the host header. I think they're a little bit reluctant to and sort of relying on developers to fix this issue. But since this issue isn't a cookie cutter exploit, so it's not an SQL injection, it's not a cross-site scripting, it's a little bit more, less known about, I guess. Developers seem to have a really hard time understanding the problem, testing the problem, and fixing the issue. Penetration testers, for the most part, from what I've seen, they're not really checking these issues. I know there are some that do, and good work to those people, but I think pen testers as a whole need to test for it a bit more. And DNS servers aren't checking for rebinding attacks, which really surprised me. They pretty much allow whatever DNS record you want to chuck in, they just forward it on happily. Web browsers could also solve this issue. It won't really help with the backwards compatibility, but it would introduce some other issues. So basically you need a bit of a multi-layered approach to fix it. So after I'd exploited a bunch of software, I started talking to developers. I attempted to get them to fix the problems. Since it isn't cookie cutter, it was really hard to get them to understand it. I think there was one there I had about 4 months trying to get them to understand the issue and still couldn't. But I completely understand, right? When I first started looking at this research a bit over a year ago, I'm like, seriously, I can just change a DNS record and point it to something else and then run whatever I want on it? Like, that can't really work, can it? Well, turns out it actually can. Okay, so this particular demo, I got in contact with them. He wrote back, I have tried to find any generic ways to activate or configure such a prevention, but failed to find any information about that. Like I said, it was reported well over a year ago. It's still present in their bleeding edge branch. Because of that, I'm not releasing my code. However, you can go through the video. I also haven't included the name in any of these slides because I don't really want people going out there and breaking into people's houses. But it's pretty easy to figure out. I think Pat already clicked on to at least part of it. So the next one I looked at, this is a developer that I guarantee a vast majority of the people in this room are using their software. So this is the one I actually spent 4 months providing screenshots, multiple POCs, videos, detailed explanations. It went on and on and on and on. And at the end of the day, they said, from our testing, it appears this vulnerability impacts versions who are running across HTTP on their local network. If a server instance has enabled HTTPS, then this attack is not possible to perform. That's not really the case. So I think they misunderstood. So I even sent them a proof of concept and video of me showing them that it does work over SSL. But yeah, apparently they didn't really get that. So their solution to this, and I got a whopping $100 for this bounty. So they closed the issue and they decided to add a line into their documentation saying users should enable HTTPS and closed it. So yeah, HTTPS has nothing to do with this. Yeah, that's not a good thing. Okay, so protections. It's pretty dismal, really. DNS Masquerade can detect some rebinding attacks, so if you're using that, check out some of the options for that. pfSense actually has some pretty good stuff. I believe a while ago someone reported DNS rebinding in pfSense's web admin interface itself. So when that happened, they actually put in some protections for their DNS stuff. Awesome firewall rules can really help. If people can't access, say, smart home controllers when they shouldn't be able to, it kind of limits the ability to do this attack. You can, of course, install the no-script plugin, but then you're surfing the internet without scripts. That's not terribly practical as well. I've heard DNS Watch does have some protections in it. I've yet to be able to actually get through that and see how well it works. But ultimately, this isn't a single fix solution. The problem has to be fixed on multiple layers, so the DNS, web browsers, libraries, and individual code bases. So the next thing I did was I wanted to look at the actual DNS servers and see, you know, does anything out there actually protect against it? It turns out not too much. So surprisingly, OpenDNS actually did a pretty good job of blocking my attacks. There were ways you could sort of get around it in certain situations, but yeah, no, most of them just failed miserably and let anything through. So a lot of these were tested at the end of last year. I assume they're still the same. Google I did test last night, so I know Google's still vulnerable to all this stuff. Okay, so takeaways. I guess the main takeaway, DNS rebinding is still everywhere. So the InfoSec community needs to, you know, spend a bit more time looking into this issue, particularly in software and not in routers and IoT stuff. More software needs to be implemented at multiple layers, DNS servers, web browsers, libraries. And so if you're going to take anything away, if you're a developer, check your software, make sure you're checking and validating the host header and denying it people if it's not correct. If you're a pen tester, check for this in all the web services that you audit. And lastly, if you're a red teamer, it's a really great firewall bypass for an attack chain, particularly when it comes to DevOps setups. Yeah.
Some bounty people are all over this.
I actually haven't, so I looked at bug bounty programs and there wasn't actually a category for any of this. It was really hard to actually choose a category that this.
But they use it to get the thing.
Yeah. Yeah, it by itself, it's really not that useful. It's only when you find something else to use it with, or if they're lacking some other protection somewhere, then it becomes really useful. Otherwise, by itself, it's nothing too special. So thank you for listening. I hope everyone has learnt something from this talk. I hope at least I get a couple of people here to go out and look for some of these issues in their environment. And thank you to my current and my past employers, so Telstra and Context. They were kind enough to give me time to research and create this presentation. And I don't know if we've got question time now, but I will be available afterwards anyway if anyone does have any questions. Thanks.
All right. So I just want to point out too that that was Matt's first con talk, and I think you hit it out of the park there, pal. That was really good. So I got a question, right? Like you were talking about how this needs to be fixed in multiple places. Like forget about domain name service operators like fixing this, because, you know, it would have to be quite, you know, like many different parties would have to fix that. Forget about this disappearing on networks as a viable vector, and for people to actually check things like host headers, like that's not going to happen. But then you mentioned they could fix it in the browser. And I could see that one very simple defense to this could be that, you know, the browser might detect when something goes from being, you know, unreserved IP, you know, to all of a sudden resolving as a reserved range. Like that, you would think would be something that would be pretty easy to detect, and there's only like 3 or 4 organizations that would need to make that change to fix this. I mean, wouldn't that squash this pretty effectively?
So it would certainly help. I mean, it's not going to resolve the issue at least straight away, because you've got so many old versions of browsers out there. I know there's certain companies, governments, whatnot, that have requirements to use older browsers. But it would certainly help.
Yeah.
You're always going to have those edge cases either way.
Yeah.
So,
but I mean, at the moment, it's not an edge case, right? And that's the thing that I think is really interesting about the state of DNS rebinding, is it's everywhere.
What actually blows my mind is, originally when I started looking at this, I tried Chrome and Firefox, and it took about 2 minutes to actually run a DNS rebinding attack on those browsers. For some reason over the last year, that's changed, and now it only takes a minute to run.
Yeah. Yeah. And I mean, you can do things like you can grab default creds for things that you might be likely to find, you know, at your target, and, you know, just cycle through. I mean, there's a lot you can do here, and it is kind of surprising how, you know, like everybody should be doing this.
Yeah, I know from history, oftentimes when you get into an internal network, people are pretty laxed with creds, so there's often a lot of admin or admin password type logins, so pretty sure you could password spray this and get a lot of shells that way. Yeah,
that's it. So who's got questions? Got one down there.
Can you elaborate why TLS doesn't help? Because one of the browsers making requests to.
So to clarify,
the question is, why won't TLS squash this?
So to clarify, I've actually only tested it on running a attack server, running an unsigned certificate and an internal web server running an unsigned certificate. I haven't actually tried it with a signed certificate, so that's going to be the next area I'll look at. However, most of the cases I've seen of this, they're running unsigned certificates anyway, so it seems to have no impact. I don't know why the browsers aren't checking it, but as Pat said earlier, it's another thing they could add in.
Yeah, it's on an internal network, it's all going to be unsigned crap anyway, and then going to make that as frictionless as possible.
Correct.
And that's why it's still going to work. Who's got other questions? Right here.
So it seems like a pretty targeted attack. Is there, is prerequisites to it going to be knowledge of the existing network that you're trying to hit?
So in my particular attack, you needed to know the exact IP address internally to hit. I think I mentioned it briefly earlier that you can actually pull down what their internal IP address is with a bit of, I think it's JavaScript kung fu. You can actually pull down their...
So if you hook them with beef first and like even in the same thing and then pass that back and then
beef
you've got
actually
their range.
have a DNS rebinding module in it. So you can actually do it that way, and then you can either use a combination of subdomains or WebSockets is probably a bit faster to actually go through the entire subnet range and find the IP address. If you do that kind of attack, then all you really need to know is if they're running that software, or hopefully if they're running that software.
You can pretty much do internal scans doing stuff like this and just cycle through. Once you actually know what the subnet is, you can just hit everything. Yeah,
I've tried it briefly with a 256 IP address range, and it ran in, I think the whole attack took about 2 minutes.
There you go.
But I'm sure you can do bigger ranges.
So IPv6 would be...
Possibly. I haven't actually tried that
Well, yeah,
one.
I mean, you're going to have a bigger space, right? It's going to take too long. But you can start passing info back too, right? Like if you cycle this thing back to your external domain, you don't even need to do that. But I mean, I'm saying you can scan a subnet and then like...
Yeah, so originally I was actually rebinding back to my external domain to exfiltrate data, and then I'm like, why am I bothering wasting an extra minute doing this? So I just called my domain directly. So you can exfiltrate data pretty much real time.
Yeah. We had other questions down here. Yep.
Sorry, is the OpenDNS protection, is that blocking RFC 1980 addresses?
The question is like, what was the open DNS protection there?
I'm not sure. It's kind of a black box. I haven't been able to find any information on exactly how they do it. All I know is that it doesn't work, and they've publicly come out and said that they do have protections against it. They just haven't been specific into what protections.
Are you setting you're setting a stupid short like refresh time on the zone file there, right?
So it's a completely custom DNS server in my case.
Okay,
so
zero TTL.
It literally responds to anything with my IP address is 1111 unless it's the right attack domain, in which case it will return an A record for its own IP address.
And what's the TTL?
I don't think there is one.
Okay.
Yeah. So it's a really dumb DNS server.
Yeah, okay.
It won't hit any standards. It won't do anything properly.
Yeah.
DNS will just recursively send back any results you give it.
Yeah.
So you don't need to actually spend too much time on doing a proper DNS server to exploit this.
Just break the standard, yeah. Anyone else? We got one more over here.
What are the makers of the embedded web server, Jetty, doing to try and engage with consumers and hobby to solve this kind of problem?
Yeah, what's Jetty doing to stop this? I'm guessing the answer is absolutely nothing.
So I've passed all the information along to them quite a while ago, and I've never heard anything back. I sent another one asking, what's going on here. Still no response. So I didn't want to put it onto their public bug tracking system because I didn't want everyone to know about it, and then I go and do a talk on it, go figure. But yeah, I didn't want to originally, like a year ago, put it on their bug tracking system. So I've sent them emails, haven't gotten any responses. I know I'm sending to the right email. It's up to them at this point. But
all right, sorry, we're going to move to the next question because we're really running low on time. Tim, you had one. Oh, sorry, no, it was Matt.
So I just wanted to say that I can totally understand why it's actually not really practical to check the file server, because you're running an embedded device and you really have no idea what is the host supposed to be, because that depends on DNS.
Yeah, so the question is really like, he understands why it's difficult to check the host header because that device probably isn't going to know what its host is supposed to be, right? So, yeah.
Well, I mean, there's no reason you couldn't look up what your domain is meant to be from the actual system and use that, but
if it's not set.
Yeah, if it's not set, I mean, that's the state of things, right? Like, deal with DNS rebinding attack, I guess.
All right, well, that is Matt Dobinson. Thank you very much. That was a great talk.